Hello everyone, welcome to this video. You can call me Pam. In this video we are going to talk about deep links, why deep links are used in mobile apps, and how if wrongly implemented they can lead to devastating attacks. And we are going to look into the types of attacks that are associated with these wrongly implemented deep links. We're also going to see some practical part of these attacks, and finally we are going to see mitigations against these very attacks. So let's dwell in. So let's talk about deep links. What is a deep link? Deep link in Android is a link that lets users directly access specific content inside an application. And all these deep links can be found in Android manifest.xml file. Deep links are normally used to improve user experience, and it also enables the user while using an application to have that seamless interaction. So thus improving user retention, usage and engagement. It depends on the functionality of the application. The other very important thing is easy navigation within the application. The application might be having various functionalities, and a user might need to move from one place to the other, and so you don't have to be cramming what link and which place you're supposed to go. So this deep links comes in handy, and it generally eases the usage and improves the user experience. So as you can see on the right side of the screen, the first one is a link, a normal link that we know, and the below one is a deep link. This image I took it from branch.io. The other thing you need to recognize with the deep links is it has a scheme, it has a host, and then it has a path. Normally, deep links are defined by intent filters. The functionality of a deep link and how a deep link behaves when in an application is normally defined by intent filter. And an intent filter contains elements and attributes that are added to the manifest file. So the intent filter actually dictates the capability of any app components based on URI type. So it might be a deep link, it might be an activity, it might be a web view, whichever it is. And one thing that I have told you before, you need to always keep in your mind is that any unexported activity but that has an intent filter is automatically exported, which means that activity, even if though it's not exported, it can equally be accessed by rogue applications, or it can be accessed outside of the application itself. An intent is a message, a request that can be passed between an app component such as an activity, a service, a broadcast receiver, or a content provider, so that they can be able to communicate. A request can come from one component to the other, requesting an action. So that is basically what an intent is. On the further right, you can see an example of an intent filter and how it's defined. The whole of this example of a deep link activity that is found in oversecured this is an unintentional vulnerable application developed by oversecured. There are three types of deep link formats. We have a scheme URL, we have an app link, and we have an intent URL. For those of you who don't know really what deep links are, on the further right of the screen, there is an example of a deep link whereby you click a link that, whether you've been sent through a message or through an email, once you click that link, it pops up giving you options which application you can be able to open that link with. In this case, you can see it's given you options of secure shop app, applications hardware, backup, and so forth. I know you've come across in your mobile phones. This is what we call a deep link. There are three formats of deep links. We have scheme URL, we have this scheme URLs, it was dominantly used until Android 1. Okay, these are custom made URLs normally. So a scheme is the one that is custom made, a host and a path. But in for uplinks, which is more secure than the scheme URLs, this came into play in 2015 as from Android 6 and iOS 9. Okay. In iOS, it's called universal links. Uplinks only use two schemes. It's a HTTP or HTTPS. Okay. So at least you might think or you might imagine that the problems of scheme URLs have been dealt with fully, but I guess you're wrong, because how these uplinks is implemented is that developers or the owners of this application, they create a JSON file called assetlinks.json in a server, and they specify the links that are associated with this app. Okay, so once an application is installed in your Android phone, the manifest file registers these links in the operating system of the Android. Okay, and there is a request that is sent to the server to verify these links. Okay, and once the operating system has verified this information from the server, it automatically and permanently registers these deep links, and after this there is no any other application that is going to come and register these same links. Okay, so basically that's how uplinks were came into place and came to deal with the problem that was used in scheme URLs. Okay, there is a paper that was done before by I think Lee and Etienne, and they came to realize how these scheme URLs were being used by applications, especially competing applications. So for example, if I have an Android app and there is a Google app, so I register a Google scheme for my application so that it can direct some traffic to my application, and especially if a phone, in that phone there is no, let's say, Google Chrome or whichever, there is no Google installed. Okay, so uplinks came into place to deal with this problem, but humans as we are, still people during the implementation of these uplinks, and especially in asset links .json, they incorrectly put a host, they misspell a host, or they even for example, they put a HTTP instead of HTTPS, or they put HTTPS in place of HTTP. So there is that confusion, and the whole implementation of this uplink come into nothing. So it's very important for developers to cross-check these uplinks and asset links to make sure they are the same and actually there are no errors encountered. Okay. The third one is intent URLs that was introduced in 2013. This one, you explicitly specify a package name for the target, a scheme, and an intent that is associated with it. So you specify package name and you specify scheme, and that way there is no shortcut about it. You can go through these references and you can be able to learn one or two things about deep links. Okay, so let's head over to attacks. There are quite various types of attacks, and if you are coming from a web app applications testing, security testing, and so forth, you'll be familiar with some of these attacks, and you know an attack can actually, depending on how the application posture is, you can be able to exploit. You can start with one attack, and one attack can lead, one vulnerability can lead to another one, and to another, and to another one. And finally, you know, the last nail on a coffin is RCA, which we call remote code execution. Okay, but the most common attacks associated with deep links is account takeovers. We have open direct, we have XSS, and especially with web views. And if you've watched my previous videos, you know what a web view is. A web view is, this is like a browser that is inside an application, so you can be able to view web pages inside an application. So that is what we call a web view. Then we have LFI, local file inclusion. This is normally found especially with content providers. And then we have sensitive data exposure. This again depends with how the deep links are configured, and especially if JavaScript is enabled, you can be able to capture, for example, sensitive data like cookies, sessions, and so forth. And so we, on the same note, we have session hijacking, and then phishing, which is the most common kind of attack, because this is where social engineering comes into play. And you know, in security, there is nothing as lethal as social engineering. So this is a brief diagram that I made to describe what a link hijack is and a phishing is. In the first image of link hijacking, a victim authenticates through a mobile browser, and this browser sends intent with auth token to an Android operating system. The operating system directs intent to the only app with the registered link. And the only app, coincidentally, that is found in it is the evil app, or an app that is there just for malicious reasons. So the authentication token is exfiltrated by this evil app and is sent to the evil server. And from this server, since it is controlled by an adversary or a hacker, they can easily be able to find this authentication token, and they can log into your account, thereby hijacking the whole of this. Instead of going to the rightful app, it's hijacked on the way. The second image is about phishing. Phishing is where you can be sent a malicious link by a hacker or an adversary. Once you click on that deep link, maybe you are in a browser and that phishing link is found in that browser. So this mobile browser starts an intent, okay? Then this intent is sent to the Android operating system, okay? The Android operating system sends the request to the only app that has registered the link, which is the evil app. So this evil app, it has a phishing page, okay? And this phishing page actually is a phishing form, okay? So it gives you back a request and it displays back this phishing form, and you enters your credentials, and finally the credentials are sent into the evil server and an adversary gets full control. I'll advise, please, if you have an application that is two-factor authentication enabled, or it has a multi-factor authentication enabled, please enable it. It can save you this kind of attacks. Okay, so that is a brief description of really what happens with this kind of attacks. So let's try to exploit some of these deep links. Okay, so one of a practical part that we are going to look at is Open Redirect, and this one we are going to use in Secure Shop. For this CSRF, I'm going to do it thereafter on a different video, so that we can talk about it, because I've come to realize it's an area, especially in mobile applications, that need more research. So I'm going to do a video on its own. And then we have local file inclusion. This one, there is a very good report, a HackerOne report on Periscope Android application. This is a report that clearly describes this kind of vulnerability that was found in an application, in a production application. So please take note of this link and find it and read about it. It can open your mind, you know. So let's go to mitigation first before we go to the practical part. For you to mitigate this kind of attacks, it goes without saying that you must use uplinks. Just avoid scheme URLs. And furthermore, scheme URLs are no longer used nowadays, and it's highly advisable that you should use uplinks. But even though you use these uplinks, it's not the end by itself. You must verify that the uplinks set the uplinks are set for Android auto verify to true in the manifest file. So once you put this auto verify to true in manifest file, then this uplink can be able to verify especially the asset links that is specified in a web server somewhere remotely. Okay. The second thing you need to do is to have zero trust on all data via deep links. You know, always sanitize, validate, and verify the data that is sent via deep links. And if needs to be encrypted, make sure it's encrypted if it is sensitive. And finally, always include JSON with asset links, the JSON in the web server described by web URLs intent filter. Okay. Hello everyone, once again. Welcome to this demonstration, the demonstration part of this video. Forgive me, I've just realized this video is becoming too long. So I'm only going to demonstrate the Open Redirect kind of attack, but from now onwards we are going to check all these kind of attacks one by one and start from the first step to the last step. And as we've talked and discussed before, the first step always is to decompile the application, and after you decompile, you do static analysis, and in static analysis you always start with manifest file. Okay, so it is from the manifest file that you get all this information, and this is where start you see which activity it is. If it is a scheme, for example, this is where you see, as you can see in this insecure application that we are going to use, it has insecure shop scheme, and it has a host of com.insecureshop. Okay. Also, you take note of the activity. There is this activity Android intent.action.view. You also take note of the activity that is under the intent filter. Okay. So we have a scheme of insecure shop, and then we have a host of com.insecureshop. Okay. If you go and analyze this activity, which I've told you I'm not going to detail because this video is becoming too long, you are going to see why this deep link is vulnerable to open redirect. Okay, so we are going to use this activity, and it is from this activity that we are going to launch a URL. So let's do that. So just type this. We are going to use ADB shell, and then we are going to start this activity. Okay, and then we are going to provide this URL. The data that we are going to use is, as you can see, this is a scheme, and then a host, and this is a path, and this path has a URL parameter. Okay, this URL parameter under that activation code, we are going to look into it in the future videos in detail. It doesn't sanitize whatever is being provided here, this data. So you can provide whichever site you are providing, whether it is yours or mine. For me, I'm going to provide this one, so you can still provide this one or whichever that you have. I want you to concentrate on this emulator phone, and when I enter, you are going to see how this insecure shop app is going to open, and it's going to open this page inside itself. Okay, so let's do exactly that. You can see it's opening, and it's successfully opened. If you want to know you are still inside this application, just click here. You can see we are inside insecure shop, but then it's been able to open a web page inside itself. So one might ask, I mean, what is the big deal about opening a page inside the application? There is nothing wrong with that. Okay, but this is where the skills of exploitation comes in. You know, your creativity gets activated here. You become creative on what you are going to do with this kind of attack. Open redirect can actually lead to devastating attacks, and especially if it's a website and this website has other internal machines or internal IPs, and these internal IPs, if you find them, and probably they cannot be accessed from the outside, but they can be accessed from a site that is trusted by these machines. You can actually redirect. For example, if that machine has an IP or whichever, if it is a HTTP something and it is an internal server, you can redirect to that internal server and you can access it. So it can lead into accessing sites or locations that you aren't supposed to access. Another possible attack is phishing. This can be, you can be tricked by a hacker. They send you a link and you click that link. It opens inside an application like this, whichever application that you have. It opens inside and you might not be able to tell that that site doesn't belong to the application's owners. Okay, so if it is an information they want, you are going to log into that application, you're going to provide that information inside it, and finally that information is going to be taken to a server somewhere that is controlled by whoever is behind the phishing attack. And if you provide your credentials and the application that is associated those credentials doesn't have multi-factor authentication, and also if it has multi-factor authentication but you did not activate them, then they are going to access your account and do whatever they want to do. Allow me to end this video here, and in the next video, now that we understand deep links, we are going to talk more about various kinds of attacks. That is it for now in this video. It's been long, I'm sorry, and see you in the next video.